Okay. First off, any questions? I know there's a question about number 10 on the very first worksheet, so we'll go through that first. So for number 10, what is the acceleration of a car that changes from 60 meters per second to the north? So that's the VI. Let me change colors because black was yesterday. Come on. There we go. So this is your VI, and then it changes to 60 meters per second angle, 45 degrees east of north. So that's your VF. So again, A is VF minus VI. So we're going to do the VF first, which is that. So that's 60 meters per second, and this is 45 degrees. And then minus VI. Now, you're subtracting VI, so you're adding the negative VI. So if VI was this, 60 to the north, then negative VI is 60 to the south. So we're going to add that to this. So we're going to go 60 down that way. That arrow's a little bit too big. Probably something like that. And then connect that to that. That's your delta V right there. Okay, so if you do that, because this is directly south and this is 45 degrees, that means this is 45 degrees right here. And so then we'll just use cosine law. So that's going to be, I'll just do it on my calculator. 60 squared plus 60 squared minus 2 times 60 times 60 times cos 45. And square root that to get 45.92. And then, so that's your delta V, but acceleration is delta V over t, so time is 3 seconds. So we're going to divide that by 3 to get 15.3. So that's 15 meters per second. And then the angle, we need this angle right here. Now keep in mind that, oh crap, this horizontal line, this is 45 degrees right here. So we're going to find this entire angle. So let's go sine theta over 60 equals sine 45 over 45.92. Okay, because it's the delta V that you're doing, it's not the 15. So 60 sine 45 divided by 45.92. Second sine that. And you get 68 degrees. 68 degrees. So if that's 68 degrees, but the top part's 45, then 68 minus 45 is 23. So this is 23 degrees. Okay, so then it would be 23 degrees south of east, which is like, or 22, I guess, which is the same thing as 68 degrees east of south. And that's that part. Okay. Any other questions? Any from the equilibrium worksheet?
Yeah, I have a question.
Yeah.
But it's not from the worksheet. It's actually it's a question. So if the question is asking for the weight of an object, the answer should be kilograms, right? Not newtons.
No, weight is always measured in newtons.
Oh, it's the weight.
Very common misconception. Weight is newtons, mass is kilograms.
Okay. Okay, thank you. I just was confused with that.
Yeah. Yeah, so for all of you, like, you know how you have, this is a physics 11 concept, but it's worth noting. So especially when we get to circular motion, if you have an object sitting, like, let's say you're standing on a scale. If you're standing on a scale, FG is pulling you down, FN's going up. What the scale is reading is your weight, air quotes weight, which is your FN. Now, if you're just standing still on a scale, your FN is equal to FG, which is mg. And so your weight is measured in newtons. But notice how it's mass times gravity. So it's dependent on your mass, which is why mass is often called weight. But it's not the same thing. Weight is a force in physics. Okay, any other questions? No. Has everyone had a chance to actually work on the equilibrium package, the worksheets? No answer.
No, I couldn't. I didn't have a chance because I was working on my quiz.
Okay, I was worried about that. Is everyone in the same case, in the same boat?
Yeah, I was also doing the quiz. So.
Okay. Okay, I want you guys to work on equilibrium before we start torque. So maybe I'm just going to cut this short, and then we'll do the lesson later if we have time. How does that sound to everyone?
Yeah, sounds good.
Okay. With the potential that we might actually not do a lesson today, and we'll just do 2 tomorrow.
Okay.
And that also gives the new people a chance to catch up, because we've had 4 new people since last night. So, okay, we'll do that. I will. I'll shut this down, and then we'll. I'll message you guys later and ask to see where you guys are at. So yeah, that's it, I guess, for now. So I'll message you again at probably 10:30ish, and then so yeah, just make sure you come back on here at 10:30.
Okay.
Okay.